Welcome to week 4, Introduction to Grades 101. And this module, or this week, is talking about slope staking. So we're putting together a little video here to get you a jump start on this. And you may want to recall or go back and refresh. We're going to touch on this calculating slope ratio and percent grade as we're going through this little video. But first of all, I want to take a look at this overview and let you see what we're thinking we're going to learn here. It says in the week 3 module, we learned how to calculate slope ratio and percent grade. In this module, we're going to learn the application of those calculations, actually how to stake a field slope and how to stake a cut slope. So the objectives are going to be we want to be able to demonstrate the process of staking a field slope, and we want to make the adjustments in doing so when staking a field slope. We want to build it so that the vertical dimensions, and this will make sense later, after the first stake will all be 4 feet. And I'll get into that when we get into the actual stake slope staking class, which will be coming up after this video. And then we're also going to show you how to stake a slope with just one person. There's a bit of a trick to that. And then talk about how to coordinate with equipment operators when we're assisting with rough and finish grading. We'll spend a little bit of time doing that. So why do we need slopes? Probably there's a couple of, basically 2 types of slopes. There's a cut slope and a field slope. So take a roadway, for instance, let's use that as an example. When it's approaching like some existing, it's going across country, first of all. You know, when we're laying this thing out, we're figuring out at the same time what we're going to have to do in what situations, because the terrain's going to change on us, but we have a specific route to follow. So using a roadway as an example, when we're approaching existing terrain that has an elevation that is much higher than you know what we are now, then we're going to have to cut through the hill. We can't go up the hill because it'll probably be too steep. And if we continue to go up and down a lot, we'll use a whole lot more asphalt. We'll use a whole lot more base material, etc., etc. So we're going to have to cut through some of that hill because it's going to be too much of an incline for trucks and cars. So once we cut through there, I don't have, there are pictures, you can look them up and you can look along the side of the road. Once we cut through that hill, we're going to have a wall on each side. We have to, in most cases, slope that wall for different reasons. One is so it won't erode and all slide back down in the road. Now, if it's solid rock and we've dynamited and scraped and clawed and cut our way through that, and we have vertical walls of solid rock behind us, we may not have to slope that because that will be really hard. We may want to bench it, you know, to help from the what we call raveling, from big rocks raveling off the sides and rolling onto the highway. If you've ever driven through mountainous terrain, you've probably seen that. So we'll probably want to do that. So the steepest slope is going to be 1-to-1, and probably don't want that. We'll probably bench it so that the overall slope, even in solid rock, is going to calculate out to be, even though it's not smooth, it's going to calculate out to be 1.5-to-1. So really we don't need a slope, but it's always good to put it in there in solid rock. Now if we're, same thing, we're still going along and we run into another hill, but it's not solid rock. it's different materials, maybe even a little sand, a little clay, things like that. But it's a bit, it's much coarser than solid rock. In other words, it's got a lot of voids in it, and it tends to slide, slab, or erode. You know, we need to get vegetation on it. Uh, Also, we got to consider highway maintenance, such as mowing. You know, you can't mow on a one-to-one slope with a tractor and a and a brush hog. You're going to turn over. So that's part of sloping also. So a lot of the slopes you'll see that's not going through real uh, dense or solid rock are going to be 2 to 1, maybe 3 to 1, 4 to 1, maybe even 6 to 1, depending on, you know, what kind of terrain we have and how much vegetation we can get on it to kind of cut down on the erosion and those kinds of things. You're going to see now that's just roadways. Now, what if we're high elevation and we come to a low elevation? Maybe there's a large creek or even a river ahead of us. So we're up high, so we're going to have to build an embankment that has slopes on each side of this as we approach this low spot, because we're probably at some point we're not going to, again, we can't go straight up and down, so we're going to have to slowly approach that low point, and we're going to have to prepare an embankment for an approach. Now, the reason we do that is to bring that road up high, because we're going to build a bridge across this. If it's a river, that's that's a really big deal. You still have to have that embankment to approach that river. If it's just a large creek, but it's in a valley, we may want to stay. We don't want to go down in the valley all the way. We'll probably build an embankment and approach that. Now, if you want to, I don't have a picture of an embankment, but think about a levee. Maybe you've seen one of those coming off in a bay, off the offshore, things like that. Or even out in the country, you may have seen a farm pond where the livestock get their water. There's a pond dam around that, and it is sloped for the same reasons. Also, slopes, you're going to run into the need for a slope, maybe even in a residential area. The front uh, of the lot is always, of a house in a subdivision, is always going to be sloped down to, from say the slab, a little bit below the slab. We'll slope it all the way down to the top of the curb for drainage. We don't want standing water in our front yard. Same thing in the back. We may slope it toward the alley. Same thing on the right. The house on the left, you know, they both may slope into a low spot and come down to the curb. So there's one thing maybe, other than an airport, that's level, and that's a house pad. Most everything else on a construction site is got some kind of incline to it. If not for drainage, which is the number one thing, it's for the the existing terrain. We may what if we at out the we're building out from a slope, so we have this sloping down in the back of our house. Well, we're going to have to come out further and build up. We're having to come out from a real steep uh, hill from the street side, so we want to come out level. Well, when we get to the back, we want to slope that down. We can't just have a cliff back there. It's going to erode away. So you're always going to be dealing with slopes. Now, let me see if I can get this thing to work. And well, let me finish just talking about slopes. I want you to let me get back to the module. There's a couple of things I want you to see here before I go too much further. Uh, I want you to be sure, and we're going to have another video. If you can see my finger right here where it says slope staking class video, that's going to be a video. Now, just above it, this is important. Before we watch the video, I would like for you to read this here. And it's really going to be what the video is of it. It's just we're going to be looking at it while I'm talking. Let me give you an idea of what we'll see in here and what a slope looks like. So, you know, this right here is a hill, right? And our roads, this is the center of our road. It's coming toward us and going away from us. Okay. So we can't build the road slanted, right? We got to have the road level with a crown, probably 2% to go back this way and to make sure the water runs off this side. So we've got to take this existing grade, cut part of it out. We'll probably take this dirt and move it down here where we have a fill section. And then we'll have to build a slope right here, and this will be a cut slope. So we got a fill slope. Part of this is fill and part of it is cut. So we get to go through both things here. I don't want to get too much into this because I'm going to go over it again. We'll go over some stakes that you'll be seeing, and but I want to kind of ease my way back out of here and do a couple of other things. I just wanted to show you what I'm talking about. When we're building roads, we run into things like this. Okay, so let me get back out because this is going to be in our more full class slope staking video. Meantime, meantime, we're going to go back over this. There's just a little bit here. I can drop this on us right here. This thing we've seen before. Uh, to me, this is really important. Remember, there's a percent grade, and there is a ratio formula. Now, when we're talking slopes, we're talking ratio. If we're talking about that front yard, it's going to be like a 1% gradual or 2% gradual slope down to the curb. So we're going to use percent grade for that. If we're talking about the sewer that comes out of the house and goes to the uh, the city sewer line and the easeway, that's gravity flow, we're going to be talking about a 1% fall. So we'll use uh, this formula right here. This is the formula. This is percent grade vertical is divided by horizontal, and that equals your percent grade. I don't have any values in here, but if I did, we'll figure it out, and we'll do that in just a second. This is a quick review. Now, when we get down to slopes, and if we know any two of these three values, we can calculate the third. If we know that the slope ratio is 2 to 1 and we have a fall of 4 foot, the horizontal distance is going to be 8 because it tells us multiply the ratio times the vertical, the fall. Okay, want to remind you of that. I want to see if I can click over here to just give me a second here while I close this back and get us back to where do I want to be? I think I want to go back to, excuse me for a second. I got a feel a sneeze coming on. Okay, I want to show you, like I don't want to spend a lot of time, but there's so much to talk about on this. If I can give you a little head start, we'll be in good shape. Uh, I think, you should be good with this, the week 3, you just left with that quiz 3, uh, uh, was it week 3 quiz 3, uh, there's a lot to that, but it's repetition, and I'm going to review a little bit of that if I can get us over here to where these questions are. Just give me a minute so I can kind of illustrate uh, or review. Here are the questions. It's a little dark in here. A little bit better. So I got a couple of sheets over here, and you know how that is. You've been around me where I get these things mixed up. But here's the sheets I've got, and we had to go through this before the dealing with this stuff. So just, and I'm not going to go through all of them, but I want to make sure you're good with this when we get into calculating these slopes, because you're going to be doing it over and over again. Look at that first question at the top up here where it says a 1.5 to 1 slope. On a 1.5 to 1 slope, the vertical cut is 3 foot. What should the horizontal distance be? Well, it gives us the slope ratio right here. So let's go down. I need to fix this. Let's go down here to the slope circle. Let's call it that. Now, it said we had a 1.5 to 1 slope, so that would go there. And the vertical is 3 feet, so that would go there. We would put 1.5, 3, and that's probably going to be, just a sec. That's going to be 4.5. So the horizontal is 4.5, like that. So percent grade wise, do we have one of those? What would the horizontal? It's a high 90, no. Well, I think we've done, most of these are slopes. Most of these are slope. But let's say this. Uh, let's say if we had a horizontal of 100 feet, we would put it right here, right? If our percent grade was 4%, what is the fall? The vertical is the rise or the fall, the distance high or the distance low we're going to make it. So we know we're going to multiply 4% times 100. So we got to change this 4% to a decimal, and you can just, it's 2 places, but you just divide 4 by 100, you would get 0.04. And if I multiplied that 0.04 times this horizontal 100, my vertical would be 4. So that's all I want to talk about in this. Next thing I'll throw up here as you're going through the week, you'll see it come up, is the, let me get us back over here, is the, hold on. So we're back over here. I just want to point out a couple of things, and then I'm going to shut us down. As I said, you can go back and review the overview. By then, the video that we're recording now are probably stuck in there. And the under instructional resources, this is the circle thing if you want to review it. I want you to read this, and this is what this video is going to be about. This is the same stuff that we looked at here. This right here, it's going to go on and take us through all the slope staking things that we got to know. And it's not hard, it's just like everything else, and here's just new. So back here, let's see, any more reading? Of course, we'll have a quiz or two here at the end. I haven't really gone over those to see if there's anything I got in there that you don't know. Then we'll talk about culture, which is a really big deal in construction. And each company usually, whether it be organic, in other words, it just evolves uh, into what it is, or there's the better companies will decide the culture, we're going to be positive around here, et cetera, et cetera. That's probably a good tailgate. But we'll talk about how we build a fill slope uh, in here, and then when we next week after week 4 is week 5, which is your midterm. After the midterm, we're going to jump into building a cut slope. Now, the things you'll be doing will be exactly the same, except what? You'll be going in a different direction. Instead of going up, you'll be going down. So look forward to that. If you have any questions about this video, be sure and contact me. If you have any questions about anything that we've covered in the course, be sure and contact me. Okay, that's it, folks.